Hello, and I want to welcome you to one of our final discussions on factoring perfect square trinomials. This will be one of the last discussions on factoring, and for the rest of the math courses this will be a tool that you may have to use or have to remember or relearn. It's a great tool to know. Alright, so for this one, perfect square. If you see here, there's a squared term, and what does this really mean? It's referring to just writing the term two times as looking at it as a product, and the product of two terms, we're going to have to use the FOIL method to simplify. When we do that, we're going to have to multiply the x times the x found in the second term. We're going to take the same x and multiply it by the 3 in the second term. Take the 3 and do this and multiply by the x, and then finally multiply the two 3's together. So here was the F, here was the O, here was the I, and the L to make up the FOIL method. Now, let's just go through and use our method. So we have x times x plus x times 3 for the O. For the I, we have 3 times x, and finally for the L, 3 times the 3. We go through and simplify. We have x squared, we have 3x plus 3x, and finally plus 9. To simplify the middle terms here, we have x squared plus 6x plus 9. Okay, if you notice, the things that multiply together to give you the 9, that term right there, add to give you the 6. So if you look at the 3, if you add the 3's together, you get 6. If you multiply them, you get 9. So you can go from one step to the next just by knowing what you're looking at. Okay, we're going to look at some examples, but first let's just have a refresher on sign patterns when factoring trinomials. A positive constant in a trinomial tells us to look for two numbers with the same sign. The sign of the coefficient of the middle term tells us whether the signs are both positive or both negative. If positive, then both signs are positive. If negative, then both signs are negative. 2. A negative constant in a trinomial tells us the sign of the larger of the two numbers. The sign of the coefficient of the middle term tells us the sign of the larger of the two numbers. If positive, then the larger number is also positive. If negative, then the larger number is also negative. Alrighty, so let's look at some examples using factoring perfect square trinomials. Okay, so examples, the instructions will be just to factor. Okay, so if we have just a coefficient of 1, we know we can go ahead and set up our two sets of parentheses. We have the x squared, so let's just write an x on both sides since that coefficient of 1 is there. Our positive sign of c tells us to use both the sign of b, which is positive, so x's for both, or pluses, excuse me. Now finally, what will multiply to give 4 that adds to give 4? Well, just write these out. If you multiply 1 and 4, you get 4, and if you multiply 2 and 2, you get 4. But adding these together, this will yield 5 and this will yield 4. So let's use the 2 and the 2 in place of those parentheses. Now we can actually simplify this further. That's the same term written twice. In using our rules of squaring something, we really know that we can write these two terms as one using the second power rule. Okay, looking at the number 2 example, looks a lot similar except there's one little change. The sign of b is negative. So let's just go ahead and do what we were doing. So a positive 4 for c. Well, to write out what will multiply to give us a positive 4, a 1 and a 4, and a 2 and a 2. And just as before, we want to open up our two sets of parentheses. The coefficient of 1 in for this x squared tells us to go ahead and let's write an x in both. Okay, we use the sign of C. It's positive, so it says to use the sign in each side as the same sign found in the B term, which is negative, so we'll write a negative on both sides. Okay, which of these, if we make these both negative, would yield a negative 4? And just as we've seen in the past, the negative 2 and the negative 2 will yield a negative 4 when adding. So let's write 2 in for each. And just as before, we can simplify these two terms as just one term being squared. Let's keep going. We look at example 3. There's one thing you can do before you jump in to start multiplying the methods that we have in the past. Each term is divisible by 4, as you can tell. So what might be a good idea to do is go through and pull out a 4. We can't pull out any variables because there's not a variable in the C term. So let's go through and use our factoring. So we say this first term divided by 4. We're going to be left with x squared. The second term right here divided by 4, we're going to be left with a negative 2x. And finally, this plus 4 divided by 4 is just plus 1. So we need to see if we can factor out this trinomial even further. So we have 1. And what are the things that multiply together to give us 1? Well, that's just 1 and 1 because 1 is prime. And let's go ahead and write the 4, and we'll want to write our two sets of parentheses because this is a trinomial that can be broken down further. The coefficient of 1 tells us just to go ahead and write the x in for those two places. The sign of C tells us that it's positive, so we want to write in each blank the same sign found in the B term, which is a negative. So write a negative in each place. And really the only thing we have to work with are the 1 and the 1, and as we tell, if we were to make both of those negative, we will multiply those together to get a positive 1. We add them to get a negative 2. So we just write a 1 in each case. And that is how you would factor that. Okay, looking at problem 4, as you can tell, each term will be divisible by 3, so we can actually factor out a 3. We take the first term, divide 3, or x squared divided by 3, we'll just be left with x squared. The middle term, minus 12x divided by 3, we have a negative 4x. And finally, a positive 12 divided by 3, we're going to have a positive 4. Okay, so let's use our rules we learned before. Place our 3 in our two sets of parentheses, and if you will notice, we did what is in red right here, x squared minus 4x plus 4. That was actually the same problem found in number 2. So we can just rewrite what we had before in these two parentheses, x minus 2, x minus 2, because we're just copying what we did in the example 2. And just as we did before, we knew that these two terms can be written as one term being squared, so we can just write 3 times one quantity of x minus 2 squared. And that's all you have to do for that.